In this video, what we are going to talk about is kinetic energy. So what kinetic energy is it's just the energy of motion. So anything that is moving has some amount of kinetic energy. It is related to how fast it's moving, and we'll talk about that when we get to the formula. The big thing to know is that it is a scalar value. So again, it's a magnitude only. There's no direction associated with this. Just like all of our other types of energy and work, it is measured in joules, or J. Kinetic energy, so KE, equals 1/2 mv squared. Again, like I've said, kinetic energy is measured in joules. M is mass, and that's measured in kilograms. And then V is our velocity, which is meters per second. So it does matter how fast it is going. And if you notice, our velocity is squared. So that means the faster that you double its speed, you're actually going to end up quadrupling the amount of energy, to where if you double the mass, you're only doubling the kinetic energy, and it has to do with the fact that it's being squared. So if you put a 4 in there, it becomes 16. 2 is a bad example because 2 squared is double of it. Anyways, for our example problems here, so we have a 60 kilogram student running a uniform speed of 5.70 meters per second. What is the kinetic energy of that student? So KE equals 1/2. Almost forgot that. 1/2 mv squared. So 1/2. We're told our mass is 60. Our velocity is 5.7, and that's going to be squared. So when we grab our calculator, you should get something in the neighborhood of 975 joules. Yeah. Because again, we only need 3 significant figures, because this number has 3 sig figs. This number has 3 significant figures. So our answer can only have 3. That's why I rounded there. For the next one, so the kinetic energy of a 2.1 kilogram rotten tomato is 1.00 times 10 to the third, or 1,000 joules. So I want to know how fast it's moving. So now we're finding its velocity. The first thing I'm going to do is I'm going to do some rearranging. I'm going to do this up in the corner. So KE equals 1/2. Clean that up. I keep wanting to jump to the potential energy formula, which is mgh. 1/2 m times v squared. If I multiply both sides by 2, oh, it's not going to let me write it there. So if I multiply both sides by 2, I end up with 2 KE equals m times v squared. I then divide both sides by m. I get 2 KE over m equals v squared. So we take the square root of both sides. We get our nice, neat formula. So v is going to equal the square root. I'm just going to plug my numbers in here. So 2 times by 1,000 divided by our mass, which is 2.1. And in fact, you might want to write this formula here down, that V equals that whole chunk there. So what you end up getting for your velocity here is and we need two significant figures because of the 21 here, or 2.1 here. So it is 31 meters per second. Is how fast it's moving. So there's our answer.